Assalamualaikum and very good morning to everyone. Today I am Siti Nur Farhana binti Nur Azman and Siti Nur Shikin binti Parman will present about gas stoichiometry. Learning objective of this topic is to calculate volumes of gases consumed or produced in a reaction using gas stoichiometry. So, what is gas stoichiometry? As we know, stoichiometry is the quantitative study of the relative amounts of reactants and products in chemical reactions, while gas stoichiometry involves chemical reactions that produce gases. Stoichiometry is based on the law of conservation of mass, meaning that the mass of the reactants must be equal to the mass of the products. This assumption can be used to solve for unknown quantities of reactants or products. Next, stoichiometric calculations involving gases. It allows us to convert between mass, number of moles, and most importantly, volume of gases. The following relationship make this possible. 1 mole of any gas at standard temperature and pressure, 273 Kelvin and 1 atm, occupies a volume of 22.4 liter. While the above relationship is an estimation, it is a relatively good approximation at STP and can be used reliably in calculations.
Next, we move to the example calculation for gas stoichiometry. For the question, calculate the volume of oxygen in liters required for the complete combustion of 7.64 liter acetylene, which is C2H2, measured at the same temperature and pressure. So for this question, they had given the equation, which is 2 moles C2H2, react with 5 mole of oxygen, we produce 4 moles carbon dioxide and 2 mole of H2O. So for the solution, for this question, we can see here the keyword, which is the same temperature and pressure. So because of that, this question used Avogadro law, which is the relationship between moles, which is N, and the volume, which is V, at the same T and P. T means temperature and P means pressure. Okay, so from the equation, 5 mole oxygen, because we want to calculate the volume of oxygen, so 5 mole of oxygen consists of 2 moles C2H2. Therefore, we also can write 5 liter oxygen consists of 2 liter C2H2, which is acetylene. So the volume of oxygen that will react with 7.64 liter C2H2 is given, which is here in the question. So we just multiply 7.64 liter C2H2 with 5 liter oxygen, over 2 liter of acetylene, which is C2H2. So liter C2H2 we can cancel with liter C2H2 here. So we just multiply 7.64 liter with 5 liter oxygen. So we got the volume of oxygen, which is 19.1 liter oxygen. So this is the answer for this question. Next, for the exercise 10 in the gas stoichiometry, the question, CH4 burns in oxygen, producing carbon dioxide and H2O. A 1.22 liter CH4 cylinder at 15 degrees Celsius registers a pressure of 328 kPa. So the question, what volume of oxygen at XDP, which is 22.4 liter per mole, will be required to react completely with all of the CH4? So for the solution, at this question, they had not given the equation. So we must to do the equation first. So CH4 react with oxygen, produce carbon dioxide and H2O. So we must to balance it first, the equation, which is C1 here, C1 here. So C is balanced. So for H, hydrogen, and here just 2 hydrogen. So we must to put 2 here. So 4 hydrogen, so it balanced. So here just 2 oxygen, and here 2 oxygen, 4 oxygen for the product, and here just 2, so we must to put 2 here. Okay, so the equation is balanced. So from the question here, they had given the pressure, which is 328 kPa, temperature 15 degrees Celsius, and the volume, which is 1.22 liters CH4 cylinder, CH4. So because of the question want to in STP, so we must to convert it to ATM first, which is 328 kPa divided by 101, 3.325 kPa. So we get 3.23 ATM. The temperature also we must to convert to Kelvin, which is 15 degrees Celsius plus 273 Kelvin. So we got 288 Kelvin. So the volume is just right 1.22 liter. So we use PV equals to nRT because all of the information are given. So we just put in the formula. So in this formula, we want to find the number of mole. So N equals to PV per over RT. So we just put in 3.23 atm multiplied by 1.22 liter divided by 0.08206 atm multiplied by 288 Kelvin. So we got 0.167 mole CH4. So we do the stoichiometry. 1 mole of CH4 because at the question he asked for all the CH4, so here we use the CH4 and the oxygen. So 1 mole of CH4 consists of 2 mole oxygen. So we just here we had found the number of mole of CH4. So we just put in the stoichiometry, which is 0.167 mole CH4 multiplied by 2 mole oxygen over 1 mole CH4. So 1 mole CH4 here and 1 CH4 here, we can cancel it. So we just multiply 0.167 mole CH4 mole multiplied by 2 mole oxygen. So we got the mole of oxygen 0.334. So because of the question want to in at the STP, so at STP we just multiply the number of mole of oxygen with 22.4 liter per mole. So the answer we got 8.28 liter. So this is the answer for how many grams of H2O are produced. So we just use the same equation, CH4 react with 2 oxygen and produce carbon dioxide and 2 H2O. So we just do the stoichiometry because before this, in a question, we had found the the volume of oxygen. So we just use it. So 2 mole oxygen consists of 2 mole H2O. So 0.334 mole of oxygen multiplied by 2 mole H2O divided by 2 mole of oxygen. So we can cancel mole of oxygen and mole of oxygen here. So 2 here and 2 here we can cancel, become 1, and we just multiply 0.334 mole multiplied by 2 mole of H2O. So we got the number of mole of H2O, which is 0.334 mole H2O. So we want to calculate the mass of H2O. So we just multiply by the molar mass, which is 2 times 1 plus 16. So the answer for the mass of H2O, we got 3.012 gram here. So this is the answer for B question. So for the C question, what volume of carbon dioxide at STP, which is 22.4 liter per mole, is produced if only 2.15 gram of the CH4 was burned? So the solution, first step, we must to change 2.15 to mole first. So number of mole CH4, we just divide by the molar mass, 2.15 gram divided by 12 plus 4 times 1 G per mole. So we got the number of mole CH4, which is 0.134 mole CH4. So we do the stoichiometry again. The because of this question at C, we use CH4 and carbon dioxide. So 1 mole of CH4 consists of 1 mole of carbon dioxide. So at here we had found the mole of CH4, so we insert in the stoichiometry. So 0.134 mole CH4 multiplied by 1 mole carbon dioxide over 1 mole of CH4. So CH4 here we can cancel it. So the answer is 0.134 mole carbon dioxide. So because of the question want to the volume carbon dioxide at STP, so we just multiply it with 22.4 liter here per mole. So the answer for C, we can got 3.00 liter. So this is the answer for C. That's all from us.